Hi friends, let's solve one more problem which is appeared in GATE 2019. This question is asked for 1 mark. So here it is asking simply consider the two-port resistive network shown in figure when an excitation 5 volt is applied across the port 1 and the port 2 is short circuited, then we are getting a 1 amps current. And in second figure it is asking what is the current if it is short circuited the terminals of port 1 and the original voltage source which is connected at port 2 now. So by looking at this circuit diagram only we can tell that this question is framed on reciprocity theorem. So by simply looking at this circuit we can tell the answer is C, that is 1 amperes. So now let's discuss conceptually. So as per reciprocity theorem, the ratio of source to its response will be same in a linear passive network. So earlier the source is connected at port 1 and the response is taken from port 2 which is short circuited. Now the response and its source are interchanged, so the ratio should be same. So it is 1 amperes again. So here 5, the current is, let's take this is I2, this is I2, the ratio must be same, so I2 will be 1 amperes. So we can understand this reciprocity theorem using this diagram. So here it is a terminal, this is a linear network actually, and a voltage source V is connected between the terminals A and B, and a current response is taking from C and T terminals, which is output side. So if we interchange the source and its response, then we will get the same kind of response for the same kind of source. So this is what the reciprocity theorem says, or otherwise we can calculate this current manually also. So in first circuit it is given there is a 1 amps current in port 2 when it is short circuited. So this 1 amps current is flowing through this 2 ohm resistor. So the voltage drop will be 2 volts, and this R ohm and this 2 ohm both are in parallel. So the same 2 ohm will be 2 volts will be appear across this R ohm resistor. So the remaining 3 volts will be appear across 1 ohm resistor. So that will be, let's say this is I, this I will be 3 over 1, this is 3 amps. So here we can easily tell what is the current of this IX which is flowing through the resistance R. So that is 2 amps clearly, because 1 amp is flowing in 2 ohm resistance and total input current is 3 amps. So the remaining 2 amps will flow through the R ohm resistance. So now we already know that the resistance, the voltage across R is 2 volts. So R will be 1 ohm. That's it. By substituting this R in the right side of the circuit, we can easily calculate what is the current I2. So that is total current, this IT will be 5 over 2 plus 1 parallel 1. So this is 2 amps. So IT will be 2 amps. This should be equally divided between 1 ohm and 1 ohm, because R, we already know that R is 1 ohm. So I2 will be 2 over 2. So equally it should be divided equally between 1 ohm and 1 ohm. So this is 1 ampere. So option C will be the correct answer. Thank you for watching. Please subscribe my channel.